Thank you to Google for having me here. And that's not a sentence that historians really get to say very often. Like, thank you, Google. It's a very surprising pleasure to get to present at a place like this. And not only is it, I probably had like the best cup of tea of my life, like at the new upstairs cafeteria a little while ago, but for me and I think lots of Americans, Google is the cutting edge of science, right? This is where American science is going in the future. So I think it's a really interesting place to talk about where American science came from and what its origins were, its character in the early United States before we've gotten to where we are now. And I'm certainly not the first historian to ask this kind of question. But as with so many questions, right, the answer really depends on where you look. And nearly everyone who's researched this has sought answers to this question in places like Philadelphia, Boston, Cambridge. And in some ways, this makes sense, right? These cities had some of the best scientific institutions and universities in Anglo-America. And they were also places that had vital roles in the American Revolution. And this coincidence allowed historians to tell a really convenient story, one in which knowledge and freedom emerged together in America, right? And historians have loved to tell this story that what made American science distinct in the early United States was this new context of liberty and democracy that supposedly emerged with the revolution. But it doesn't take a geographer to figure out that the United States was much more than this northeastern Anglo fringe. And the basic argument in my book is that American science looks a lot different when we include the rest of the country. Really the vast majority of the country. But it was not liberty and democracy that most influenced intellectual lives for the diverse Americans living throughout this territory. And throughout this huge range, there were natives, African-descended peoples, Creoles, French, Spanish, all of whom studied nature. But they did so in ways that were not influenced most by this context of liberty and democracy that we like to think about as characterizing early US science. In these places, it was imperialism, inequality, and violence that most defined how people studied the natural world. This is because imperialism did not disappear from North America after 1776. Instead, the American Revolution created a new imperial power, one that was eager to expand across the continent. And Americans don't really like to think about the United States as imperial, but it really did all the same kind of stuff that other empires do. It used diplomacy and military force to conquer new territories. It used local cooperators on the ground to get things done. And it enforced these hierarchies of difference, these hierarchies of inequality based on place, based on race. So despite the fact that Americans today love to view 1776 as this sudden shift from imperialism to liberty, people throughout most of the United States did not experience it this way. Instead, they experienced this as an era of US expansion, of yet another phase in a much longer, older history of European imperialism in North America, one that goes back to the early 1500s. So my book argues that it was this persistence of imperialism and not the rise of liberty that made early science in the early United States what it was. And this is because that just as in European empires, US imperialism led to encounters with new places, encounters with new peoples, all of which affected how people studied and applied the knowledge they developed about nature. And across the chapters in this book, I discuss this through sciences like geology and natural history and botany and ethnology. But for today's talk, I want to focus on astronomy. And I do so for a couple reasons. First of all is that astronomy was absolutely essential to imperial expansion. It's because European and eventually US astronomers, they measured the heavens to determine their location on Earth, the location of important spots, to run international boundary lines, and to draw maps, all of which depended on the stars and were essential to creating legitimate land claims. So before Google Maps, right, if you wanted to know where you were precisely, you needed astronomy, especially if you wanted to claim that land as yours or part of your nation. Second, astronomers were able to turn the individual observations they'd make of the heavens into accurate maps and other things because they shared data across these robust national and international networks. You get a sense of one of these sort of compilations of data there with the chart on the right. And since I'm presenting here at Google, the exchange of data and the creation of data networks seems like a really interesting topic, and I'd really be interested in the Q&A to discuss how the kind of networks I'm outlining here are similar or different to those for which Google's such a hub now. And third, while at first blush, astronomy might seem like one of the sciences most removed from life on Earth. In fact, I'd say that it offers a really good window into the wider world of early America. This is because astronomy in the early United States was a tool of expansion, depended on slavery and violence, was vital to these geopolitical and cultural competitions among empires, was a means of claiming Indian lands, and because astronomy reveals that then as much as now, really, astronomy in the United States was thoroughly multinational and transnational. One of the first places where astronomy and US expansion overlapped was in the Gulf South, the region that's now the states of Louisiana, Mississippi, Alabama, and Florida. When the US won independence from Britain in 1783, all of this was part of the Spanish Empire. But US officials really coveted this region. For one, they wanted New Orleans because it was this hub of trade between the interior of the continent and the whole Atlantic Ocean. And also because all of this territory seemed like prime plantation land for expanding slavery, getting super rich off cotton in particular. They had first started acquiring parts of this region in 1795. By the early 1800s, they had it all. This expansion was very successful, and it was the first of many times, of course, that the United States would expand at Spanish America's expense, something that's been going on into the 20th century. So looking at astronomy in this region reveals a lot of the ways that astronomy promoted Anglo-American imperialism. And perhaps most importantly, it shows that Anglos did not simply export scientific practices from the East into the West. Instead, these things developed through encounters in the region. And these are encounters among Anglos and Spaniards, between masters and slaves, and between whites and Indians. The earliest such encounters occurred during the Florida Boundary Survey, which was run from 1798 to 1800. You can see on the top of the map there on the left, the line ran along the 31st parallel of latitude for hundreds of miles. And a few of the boundary stones still remain. That on the south side of the stone, it said property of King Carlos IV of Spain. Northern side of the rock said property of the United States. And since this was a massive and really important astronomical expedition, we're going to spend a little bit of time digging into it as this window into early American astronomy. But astronomy was more than just the means to a geographic and geopolitical end. It wasn't only creating this boundary, this line in the sand. It was a field of competition between Spain and the US, and both sides really used this as a chance to express national pride and really compete with each other for prestige. And also, part of the reason this line was created was that Spanish and US officials wanted to try to bring order to this region, this very chaotic border region where they had little control. But the line itself actually did more to actually just prove the messiness of this place, that a place with very confusing ethnic and national relationships. For instance, Anglos ended up working for both the US and Spanish astronomical commissions. Indians ended up working both to protect and destroy this survey. And both sides ended up relying on black slaves. So to take a step backwards briefly, Spain obviously had the longer tradition of using astronomy in the service of imperialism here. Going back 300 years, it had been crucial to navigators who explored Spain's huge empire and to the cartographers who tried to map it. And a lot of these explorers were often pictured as astronomers, that astronomers were these kind of heroes of the empires, right, who used the heavens to claim the earth. And astronomy really remained a source of pride for Spanish officials going into the era of the Florida Boundary Survey. The governor of Louisiana, a guy named, Spanish Louisiana, I should say, Manuel Gayoso de Lemos, he chose the astronomer he did, a guy named William Dunbar, a local plantation owner, because he said, if I don't get an excellent astronomer like Dunbar, I'll be laughed at. That this was really considered a source of pride and, if gone wrong, shame, right? That astronomy was caught up in all of these national competitions for prestige. As in Spain and other European empires, astronomy was a source of both expansion and national pride in the early United States. For instance, right after winning independence in 1783, there was an Anglo astronomer who wrote that the extensive territories of the United States are a foundation in nature for a vast empire, and to know its geography and fix the interesting boundaries and lines, the best and only proper method is that of astronomical observation. So from the very beginning, they're thinking of ways to use astronomy to promote expansion. Also, as in Spain, astronomy was a source of kind of national pride and identity. And one of the ways you can see this is in the early star charts, these maps of constellations that were produced in the United States. These came up with new, distinctly American constellations. Like on the left, there's a picture of the bust of Columbus. My favorite on the right, the flying squirrel, which you can still see up near Perseus in the sky. Both patriotism and imperialism would mark the astronomical work of the commission of US astronomers who went down to run this boundary between Spain and the United States along the 31st parallel. The leader of this expedition was an astronomer named Andrew Ellicott. And for one, this expedition gave him a chance to experiment with new methods of doing astronomy in the field, especially methods that are ideally suited to this land-based empire that the United States was building. So astronomers at the time, and today, really believed that to do credible astronomy depended on being detached and isolated from the influences of the world, right? Something that was best achieved in these closed-off observatories and well-controlled spaces. And we still have this image of science today, right? That like doing credible science depends on being in these strictly controlled spaces. Like, think of coming in here, you have to go through the desk with your ID cards and such. And imagine trying to do your work in a place where just anyone could walk around and start touching on your keyboard and such. This idea of political control to doing good science remains very crucial. So one of Andrew Ellicott's goals during this survey was to figure out how to produce this kind of idealized detachment in the midst of a place that was poorly controlled politically and still very wild in terms of nature and wild animals and all of this. As he put it, despite the efforts of France, Britain, and Spain to tame this region, the country is yet in a state of infamy. And so he aimed to, quote, determine by experiment what reliance might be placed on observatories made at temporary stations without any of the conveniences annexed to permanent observatories. If he had thought he could achieve this kind of detachment, Ellicott was sorely disappointed. He constantly complained about the weather destroying his very expensive instruments and mosquitoes harassing him so he couldn't actually concentrate on his observations, and also human sabotage, as we'll talk about in a little bit. So this reminds us, for one, that humans doing science, right, are never really isolated from the world around them, even though they like to think of themselves that way. And this is especially true in places that are poorly controlled, places like these unruly frontier regions in particular. Ellicott also found that his social world was really impeding his effort to do credible astronomy during this survey, for reasons that are still very unclear. One of the other astronomers that was working with him accused Ellicott of having threesomes with his washerwoman and his own son, who was also an assistant on this expedition. And even more strangely, Ellicott deflected these attacks by accusing the Spanish people who believed them of being unscientific and bad astronomers. As he put it, these insinuations would have but little weight with the people of the United States. But the case is very different with the Spaniards, naturally jealous and uninformed in science, particularly so far as it relates to astronomical observations. He didn't really explain how it gets from defending himself from charges of sexual deviance to accusing Spaniards of being bad at astronomy. But this rhetorical move does suggest something about how much Anglos' national pride and prejudice really cohered at these frontiers of encounter. So Ellicott wasn't just drawing a kind of territorial boundary in Florida, right? He was drawing a national boundary, one that distinguished Anglo-Americans as peoples with distinct traits. And this characterization that he makes, right, of the United States and its citizens of a scientific people in contrast to those of Latin America very much remains part of national discourse today. So the US astronomer Andrew Ellicott and the astronomer for Spain's commission, William Dunbar, their observations of stars, planets, the moon, the sun, moons of planets, these were all used to fix the position of this boundary line. But all of this astronomical work wouldn't have been possible without the work of enslaved blacks. Black laborers carried all this equipment that needed to be carried. They cut down hundreds of trees to make it actually possible to see the heavens through the dense forests of the southeastern United States. And a lot of this work was done in the middle of these swamps and bayous. Like, you couldn't control where you went, right? You had to stay on that latitude line. So extremely dangerous and hard work. And work that the white employees of these commissions all got too sick to do from the very beginning, really. So to put it simply, this boundary line we think of as a work of astronomy, but it simply could not have been done without slave labor. And at root, enslaved labor depends on violence, the willingness of masters to hurt people to make them work for them, right? And this use of slave labor is really just one of the ways that science hinged on violence in the early United States. It's really common to think of science as this kind of essentially peaceful activity. And this is part of the appeal of science, right? We think of it as this peaceful, detached thing. But in the early United States, and I'd argue much more broadly, knowledge production often depended on various forms of violence, from slavery to direct military conquest, and even things like desecrating and mutilating dead bodies. Anyway, the U.S. split the cost of hiring the U.S. and Spain split the cost of hiring 24 slaves. Here's a list of one of the records of these slave employees that the Spanish Commission kept. The money, of course, wasn't paid to the slaves themselves. It was paid to their masters to rent out their work. And William Dunbar, Spain's astronomer, was himself a very rich slave owner, and he used these slaves most heavily during the survey. And one of the reasons he did so was that using slave labor as a way to transpose the kind of order and discipline of his plantation onto these otherwise poorly controlled spaces of the fieldwork. Remember how Andrew Ellicott tried and failed to order these spaces through his temporary experimental observatories. Dunbar had a lot more success in this quest for control because he was able to use torture and violence to recreate order and discipline. By disciplining people, he was able to do disciplined science. In fact, Dunbar would find this to be such a successful method that in his correspondence with Thomas Jefferson over the coming years, he consistently advocated that Jefferson use enslaved laborers for Western expeditions like Lewis and Clark instead of sending Anglo-Americans. So the violent coercion of enslaved laborers was able to get this line progressing. But they were ultimately unable to complete the survey because of violence against them, violence coming from local natives. As the commission worked, it started around the Mississippi River and worked east. And as it worked east towards Florida, they ran into lands dominated by Creek and Seminole Indians, who very much resented what this survey was doing, because a lot of their influence came from being able to play Spanish and US powers off against each other, right? And they feared that if this clear boundary line were run and jurisdictions were made more clear, they'd lose this kind of between status that gave them such flexibility. So there was a threat of armed violence to ending this expedition. And one of the ways that the expedition members tried to overcome this threat was actually hiring different natives as bodyguards. Groups of Upper Creeks got paid by the commissioners to travel with them and protect them from attacks by other Creeks and Seminoles. This is, again, a list of employees. These are the chiefs and bodyguards of the Creek Nation hired by Spain. A lot of other natives, though, chose to try to thwart this expedition instead of support it. And some did so by nonviolent means. Some stole the expedition's horses and scientific instruments. And these weren't actually just random thefts, that they seem to have chosen instruments that they knew would prevent them from completing this boundary. Like they stole Ellicott's artificial horizon, an instrument that you need to determine latitude. And you can't finish this line if you can't determine latitude. And Ellicott actually grumbled that, as he put it, an impertinent young Indian kept moving the minute hand on his clock, which made it impossible to determine longitude. Still, the most effective form of opposition to the survey was armed resistance. And the surveyors eventually encountered a force of hundreds of Seminoles who, and as Ellicott put it, they compelled us to relinquish our design and leave the country. So despite efforts by Spain and the United States to use this survey as a chance to show off their national pride and power, it was actually Indian power on the ground that determined its ultimate success. For one, this is an important reminder of who was still actually in charge in this region. It was still Indian country. But it also shows some of the other ways that science could hinge on violence. It would be 20 years, in some places 40 in others in this region, before the United States had done enough of a military conquest that they controlled those spaces enough to do science in ways they saw as credible and safe. And this would keep going throughout the expansion into the West, too, where people studying everything from natural history to astronomy either were preceded by the US Army often or were embedded with them. That a lot of time these forces of soldiers out in the West fighting Indians and Mexicans had naturalists and astronomers and geologists with them who were taking advantage of the safety provided by them. So by the late 1790s, the United States had joined these European empires like France, Britain, Spain, and competed to control this geopolitically valuable region in the Gulf South. And like these other empires, the United States relied on local cooperation to do this. Simply none of these empires had enough power to just send in their own people and control these. They needed people on the ground as local experts, local power brokers. And one of the most influential of these guys was the astronomer William Dunbar. He had held plantations in West Florida, what's now the little toe on Louisiana sticking east of the Mississippi River, from during eras of British, Spanish, and ultimately US rule. But far from being a patriot for any of these different countries, he really thrived by switching allegiances among them, and sometimes holding these allegiances simultaneously. And this portrait of Dunbar, the guy in the middle, it's hanging up in Natchez now. And the story behind it is actually that when it was originally painted, he had a red coat because Britain was in charge of West Florida at the time. But after the region fell under US control, he had this repainted to have a black coat like a distinguished Republican, literally a turncoat, right? And here we see another way that looking at the rest of the country gives us a different look at science in the early United States. That one of the things that historians have almost all agreed on is that a kind of shared patriotism made American science what it was. But throughout most of the country, these people had ambivalent allegiances at least, and some of them were directly hostile to US expansion, to US rule, right? So Dunbar really became a master of manipulating imperial officials and sort of having this in-between status between these empires in order to improve his own wealth and status. And he made very similar arguments to the patrons of the officials in these different empires to get more money. He told Manuel Gayoso de Lemos, the governor of Spanish Louisiana, in 1798, as he was getting ready for this Florida boundary survey, that he should get paid a lot more than the US commissioned because, quote, the high dignity of a great and ancient monarchy, when but in competition with that of a newborn republic, demands some distinction. And this worked. Gayoso gave him an enormous raise, gave him all of this land, and even gave him servants to attend him during the survey. But this line itself actually put Dunbar's plantation outside of Natchez, Mississippi, north of the line in US territory. And so Dunbar had to start looking for similar patronage from US officials. And he had the most success with President Thomas Jefferson. In 1804, Jefferson hired Dunbar as the leader of 2 scientific expeditions, offering him $3,000 compensation. Dunbar was insulted. He wanted more. He told Jefferson that, quote, when a great empire talks of compensation, this ought to be adequate to the importance of the service and honorable to the government and to the individuals. And just like Gayoso, Jefferson fell for this play on national pride and prestige, and he upped Dunbar's pay. He also knew that he depended on him, right? So these kind of negotiations were really typical of how imperialism had worked in the Spanish Empire, like this contested place where weak officials really had to rely on local cooperation if they wanted to get anything done. Individuals like Dunbar had really thrived in this system of negotiated authority, and they could continue to do so under US rule, because the United States, just like Spain, was, as Dunbar put it, this great empire that also was overextended, also relied on local cooperation. So we can see from examples like this how Spanish ways of combining science and imperialism persisted into the era of US rule, and they did so largely because of the selfish and self-interested actions of guys like Dunbar, these men of science on the ground. So William Dunbar and Thomas Jefferson, they maintained this correspondence for years in the early 1800s. And it's fascinating to see how new scientific practices emerged from their exchange of letters across these hundreds of miles. In this sense, too, the United States was very similar to European empires, where scientific knowledge didn't really diffuse from Europe to the world, right? But actually emerged in this kind of back and forth conversation between colonies and metropoles. So for instance, Jefferson and Dunbar developed together a new method of determining longitude on land through astronomy, one that was ideally suited for the US, this kind of land-based empire that the United States was building. So European empires at this time had really struggled with this question of how to find longitude at sea. And this is a challenge that was solved right around this same moment by a guy named John Harrison, who basically invented a really, really good clock that could be carried on ships. But for the US, finding longitude at sea wasn't as important as being able to do so on land. After all, they were building this land-based empire. So what Jefferson really wanted was a way that a single explorer traveling with sturdy, cheap instruments could find out their longitude through observations. You couldn't carry around one of these Harrison chronometers with you. It would break. It was big and heavy. So this challenge really came to the fore as Jefferson starts planning these western expeditions after the Louisiana Purchase, things like the Lewis and Clark expedition. And Jefferson starts consulting astronomers and mathematicians throughout the country looking for answers to this problem. And some of this advice was useless at best. There's this image on the left. There's an inventor named Timothy Clark who sent Jefferson his design for a device for finding the longitude. And the way he explained it is that there would be a plumb line with the weight that you would fix at a particular longitude. Then as you rolled this thing east to west, this line would tilt to stay gravitationally locked at your original longitude. This doesn't work. There's no way this could possibly work. But it shows the extent to which this longitude question, right, became this national scientific endeavor, both for astronomers and mathematicians, but also for these tinkers and inventors. Jefferson had a far more productive exchange with Dunbar, who was in fact his most distant correspondent on this. The two fine-tuned a method of determining longitude through lunar altitude observations, which was different than the usual stellar angle observations, which we don't need to get into, but basically measuring the angular distance from the horizon to the moon, and then comparing those observations with those in a place with a known time, like the observatory in Greenwich, where the zero line of longitude is. And Dunbar explained that, quote, "This method was much better calculated for travelers by land than voyagers by sea, and a single observer with a good altitude instrument, though deprived of a timekeeper, may still make useful observations for the advancement of geographic knowledge." So all of these things that Jefferson had wanted from this method. So this was a method that was really created with a new emerging kind of American icon in mind, right? Like, one of these guys like Meriwether Lewis, these solo heroic explorers who could go out and figure out where they were and make better maps in this kind of low-tech, rugged American way, a distinct American science for a distinct American empire. So guys like William Dunbar and many other astronomers collected all of this astronomical data. Dunbar had built his own observatory on his own plantation, in fact. But all of this data had to be compiled. It had to be calculated and compared in order to figure out things like longitude through comparing observations in different places. And one of the key figures in the United States in interpreting and calculating all of this data was the Spanish astronomer, José Joaquin de Ferrer. Ferrer had been an officer in the Spanish Navy and had served in Spain's Royal Observatory in Cadiz. And around 1800, he moved to New York, really bringing this tradition of Spanish excellence in astronomy to the United States. Ferrer became deeply involved with the US community. He became a member of the American Philosophical Society in Philadelphia. And it was him who really was in charge of taking all of this raw astronomical data flowing into the Philosophical Society, turning this into useful geographic knowledge, things like latitudes and longitudes that could be used to make maps. And he was able to do this even more precisely because he was also tapped into this larger international network. He was receiving data from Spain, from South America, from the Caribbean, from Germany, from France, all of which helped to make these observations more accurate. The more data you had, the more accurate your locations could be. So Ferrer's role in calculating and synthesizing this information was perhaps most clear in 1806 during a solar eclipse. As William Dunbar had put it, this eclipse was to be seen all over Europe and North America and was thus very important for settling comparative longitudes. Basically, you could just figure out the local time where you see the eclipse in all of these different places. Allows you to have a good comparison of longitudes from throughout the whole space where you could see the eclipse. Observers from throughout the United States and Spain sent their raw data on this eclipse to Ferrer. And he was able to calculate through charts like this one on the left, where all of these places were with more precision, make better maps. On the third from the bottom on the left column, it's hard to see. It says the forest near Natchez. That's the plantation observatory that William Dunbar kept. And his observations were particularly valuable in this because they were by far the most Western. The further away, the better, really, with this stuff. And this is Ferrer's drawing of the so-called corona, the radiation that you see around the moon during a full solar eclipse. And it was him who actually coined this term corona that we still use today, talking about eclipses. So perhaps more importantly, Ferrer was able to draw on his experiences with, as an astronomer for Spain, to help officials in the United States figure out the best ways to use astronomy to promote this expansion that they desired so much. So based on Ferrer's advice, several astronomers actually lobbied Thomas Jefferson that the United States needed to build a national observatory based on the model of Cadiz. They said this model was much better than that of France or Spain. And this is actually, sort of turns a lot of our assumptions on our head. For a long time, historians have seen Spanish science as backwards compared to that of Britain, France. At the time, though, people in the US very much saw this as the model to emulate. So, in short, I'd argue that American science was thoroughly multinational from the very beginning. And the fact that historians have almost entirely excluded non-Anglos, and especially Hispanics, from this story says a lot more about modern-day prejudices than it does about the conditions of the scientific community at the time. So, astronomy is just one of the sciences I consider in this book, Frontiers of Science. But I hope that this case has provided a glimpse into an intellectual world that's just very different from our usual vision of early American science. Again, historians have usually agreed that it's this post-independence context of freedom and democratic government that set American science off on its own path. But this conclusion really rests on some very bold assumptions, even if they're widely accepted assumptions. It assumes that US territory was a place defined primarily by liberty and democracy. It assumes that American people studying nature were free and independent citizens. And it therefore tends to assume that the only truly American intellectuals were white Anglo men on the eastern fringe of the continent. But my book offers a more inclusive and I think more accurate way to understand knowledge in the early United States. This intellectual world of Eastern Anglos was neither separate from nor really all that much superior to a vaster early America populated by natives, blacks, Hispanics, Creoles. And all of these people studied the natural world. But again, it was not liberty or democracy that most influenced their intellectual pursuits. It was inequality, imperialism, and violence. So lastly, I believe that recovering this broader vision of American science matters far beyond the academic work of historians. If American intellectual history continues to be told essentially as this story about Anglos working in isolation from the rest of the continent, then it remains really easy to conclude that other American peoples have never really mattered to knowledge and culture in America. And it thus remains really easy for huge portions of the population, including voters, to rally behind a very narrow vision of America's cultural past and use this vision to justify ongoing exclusion, ongoing inequality. But if scholars and teachers strive to elaborate the many, many ways that multinational encounters have always been central to American intellectual life, then a new set of stories about which peoples and places mattered to American culture can then start to become normal. And more Americans might then start to draw on a vision of history that inspires greater inclusivity, greater humility. Thank you. And I have time for questions.
Throughout American history, there's been waves of anti-intellectualism.
Yeah.
And a lot of that is, I think, focused on or personifies intellectuals as, Eastern, like what you call like fringe of the continent. And I was wondering if there was any sort of relation between like the fact that, as you were saying, all these other people have been excluded, and then if that plays into that sort of political anti-intellectualism, it just seemed like an interesting sort of.
Oh, it does, and I haven't thought about it in those terms. And I think that's a really great point in terms of, whether or not it's a kind of resentment at exclusion or just a sense of, I live in Nevada now, and there is this sense of like, oh, these effete Northeasterners who think they know better than everyone else, right? And I think at least at the beginning, this image occurred largely because these Northeasterners wanted everyone to know that they were better than them. Like there's a very sort of clear sense of Anglo-American cultural superiority, especially in these Eastern spaces that was pushed west. I'd say now, though, it's less regional and more based on class in a lot of ways in that sense. But yeah, I hadn't really thought about this as in connection to sort of resentment of intellectualism more broadly. I think it's a really great point. Thank you all very much for coming. It's been a real pleasure speaking here at Google.